Alright guys, welcome to our first ever video for AP Calculus. This is so exciting. Today we're going to be working on the study guide. So I really want you guys to have tried this before you watch the video. And if you haven't already, please go back, try all of these, and then come looking for answers, okay? I'm really interested to see what you know before you get help, but obviously we're gonna need help. And this is not exactly the same as the test tomorrow, obviously, but if you can do all of these skills, you'll probably be more successful tomorrow. Also, make sure your binders are ready to go, all the notes are filled in, and you understand every single topic, because any of those topics we've covered are fair game for tomorrow. So, we've got a function, and I want the slope of the line that is perpendicular. Okay? Perpendicular, another word for that is normal. Okay, so you might see that. I want to know the slope of the tangent line. Whenever you see slope of the tangent line, you should be taking a derivative. So we've got derivative of g is this function. Okay, and then I want to know it at 1, so I simply plug in 1. So I get -9 plus 5 equals -4. And you're like, oh, cool, -4 is right there. But they asked about the perpendicular slope, so it'd be e1/4. Tomorrow on your test, all of the questions only have 4 options. But on this I have 5 from the old version when the AP test used to have 5 options. This is a non-calculator test. There will be some that need a calculator, but not tomorrow, okay? So no calculator for tomorrow. Please know how to do all this stuff by hand, okay? So I've got an equation here that's almost in point slope form, okay? And they want to know the value of g prime of 1. So basically, this is an equation of a tangent line. This is not a form we recognize. It's very close to point slope, but it's not quite. So there's a lot of ways to do this, but my advice is to put it in point slope or slope intercept form. So solve for y. Get everything away from y. Divide by -2, divide by -2. So I get -12x plus 15/4. No, minus 15/4 because we divided by a negative. Okay. So that's the equation of the tangent line at -1. Well, we know the derivative at a point represents the slope of the tangent line. So all you're really looking for is a slope in a way that you can understand. So put it in a slope form that you understand, find the slope, and that's the derivative at the point. This is number 3. Clearly I cut out whatever number 3 was because I didn't like it. Okay. We have sine of h plus x minus sine of x over h as the limit approaches 0. Okay, this is a derivatives test, so I'm not really asking you about limits. Okay, if you see a limit problem, it's actually a derivative problem in disguise, because the definition of the derivative, I don't like how the shadow is. So definition of derivative, as hopefully you recall, is the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, that's the definition of derivative that we learned before we learned some shortcuts. Okay, so that means that you're really just looking for what f of x is. F of x is clearly sine. So instead of doing all this nonsense, you just know that this means the derivative of f of x, which is cosine. All right. And there will definitely be problems like that. All right, next problem is number 6 on here. So number 4, I believe. I cut out a bunch of problems and added some. So the function from 0 to 8, I have graphed its derivative. Okay, this is a graph of the derivative. So this is the graph of all the slopes of all the tangent lines. Okay, and they want the equation of a tangent line. So tangent line, y equals m, x minus x1 plus y1. Okay. And they give you the value of f of 3 is -5. So y equals m x minus 3 minus 5. Okay. And to find the slope, we know it's the derivative at 3. Well, this is the graph of the derivative. So all you gotta do is 3, and you see the value. That's 2. And then it's not exactly written in the form, it's written in the other form by adding 5 to the other side. So that's why it's answer choice D. All right, for number 7, we've got a function there, a polynomial function, and it wants the equation of the tangent line at -1. Really, really similar to the first one we did, except for they want the actual equation of the tangent line, and it looks like they put it in slope-intercept. So f of x and then y equals m x minus x1 plus y1. So first, we know x is -1, so minus -1 plus y1. To get y1, I'm going to plug into the original function. Okay, so I get 4 times -1 cubed minus 5 times -1 plus 3. So I get -4 plus 5 plus 3, and that is 1 plus 3, 4. So the y value is 4. All right, for m, we know that slope is the derivative at a point. So we're going to take the derivative of this function here. So I get 12x squared minus 5, and I want to evaluate that at -1 because that's the slope at -1. So 12 times -1 squared minus 5, so that's 12 minus 5 is 7. And the answers are not written in point slope, so you're going to have to distribute. So you get 7x plus 7 plus 4, and that becomes 7x plus 11. All right, this one really, really similar to that last one on the last page. This is definition of derivative. Okay, I brought this up multiple times because it's important. Okay, so the definition of derivative is this guy. Okay, this is before we learned the shortcut. Okay, it's before we learned how to do any derivatives. We had to do this, and we had to do a bunch of algebra to get an h to cancel so that it wasn't 0 over 0. Okay, this is a hard one to do old school. So you need to realize that this is saying this is the derivative of some function f of x. Okay, the easiest way is just to identify what f of x is. So f of x is natural log x, and they want the derivative of it. And the derivative of natural log is 1 over x. And we proved that on one of our toothpick pages, I think. So your answer is C. All right. Next page. Ooh, similar question for number 9. Except for, you'll notice it's not f of x. Okay, it's actually cosine of x over 4 plus h minus cosine of this over h. Okay, so what's happened is f of x is clearly cosine. Okay, except for x has already been filled in for us at pi over 4. So essentially what it's saying is take the derivative at pi over 4. Well, we know the derivative of cosine is negative sine, and we evaluate it at pi over 4. So if x is already plugged in, it's hinting to you you need to actually plug it into the derivative and figure out the value. And we know sine of pi over 4 is root 2 over 2, and it's negative because the derivative of cosine is negative sine. So your answer is D. Right, the next problem here, number 10, is a product rule problem. The reason is because you have two different functions being multiplied by each other. This is not polynomial form. E to the x is a different kind of function than x squared. So we know the derivative is the first times the derivative of the second. Okay, I know it looks the same, but the derivative of e to the x is just e to the x, so that's making that connection there. Okay, plus the second, e to the x, times the derivative of the first, 2x. Okay. All right, so you end up with x squared ex plus 2x e to the x. All right, that's not an option. So what they've done here is they've actually pulled out common factors. So e to the x comes out because they both have an e to the x, and they both have an x. So that left this with x and this with a 2, which is answer choice C. All right, something else we haven't talked about too much recently is differentiability, okay? That was definitely in this chapter, so you might want to take another look at differentiability. Here's a good time to review differentiability. So we know it's continuous. Okay, that's last chapter. Continuous is where f of x is defined and the limit, or f of a at a specific point, right? And the limit from the left as x approaches a is the same as the limit as we approach a from the right, okay? And those two things are the same. Okay. That's continuous, that's from last chapter. You still need to know that, but we've added on a new thing this chapter, okay? We're talking about differentiable, okay? So continuous and differentiable are slightly different things, but they're intertwined, okay? So for differentiable, it's very similar to continuous, okay? Basically, it means that you can take the derivative anywhere, okay? And it won't make an undefined derivative. So differentiable means that the limit from the left and the right are the same, except for we're no longer talking about the function, we're talking about the derivative. Sorry about, I ran out of room. Okay. So the limit from the left and the limit from the right are the same, or the slopes match. I highly, highly suggest you go take a look at that differentiable lesson again. Okay. And we have 5 ways graphically we can tell. Okay, first, continuous. It has, well, we're talking about the ways it's not. So if it's not continuous, it's not differentiable. You can stop right there. If there's a hole, if there's a jump, if there's an asymptote, okay, hole, jump, that is not differentiable. You can give up right there, okay? The other ways are continuous, okay, but not differentiable. So that includes sharp turns, okay, so like absolute values. What else? Cusps. Very, very similar concepts here. In fact, a lot of people put them in one. Vertical slopes. Okay. So while you're doing your little like toothpicks, and if it ever goes straight up and down, we know the derivative of that is undefined. So that couldn't be differentiable if it has a vertical slope. And lastly, what I call intense oscillations. Okay. These are not things that make it discontinuous. These are just hints that you know. Okay. This right here, the limit from the left and the right, is really what it's about. So that was your little brief reminder about what the heck differentiable means. So anyways, we've got a graph here, and they want to know which is true. So this is a graph of the original function. So they want to know f prime 0 at 3. Well, let's go to 3. Oh, we got problems. Okay, if you go from the left, you got this tangent line. But if you go from the right, you've got this tangent line. The slopes don't match. Therefore, it's not differentiable, so I can't even tell you what the derivative is. So anything with 1 is not true. So count it out, A and B. Okay. The derivative at 2.5, so let's go to 2.5. It's right here. Let's do a different color. So at 2.5, they're saying, oh, that's a crappy pen. They're saying that the derivative is greater than 0, aka positive. Okay. I believe that's true because it's increasing and that slope is positive. I don't know what it is, but I know it's positive. So this one's true. So, I mean, I already have my answer basically, but let's go to 3 just in case. On the interval -4 to 5, so pretty much this whole graph here. Okay. There are 3 values at which it's not differentiable. Okay. Right here, not differentiable because not continuous. Okay. Here. Okay. So 1, 2, again not continuous, it has jumped its continuity. And right here again at 3 because of the slopes not matching. So that is also true. So your answer is D. 1 and 2 are true. And that's all the multiple choice. You have more multiple choice tomorrow. I believe you have 13 on the test. Or today if you're watching this early in the morning. But those are some that I wanted to make sure you knew. There's a couple more that have product rule and quotient rule. Just some straight derivative ones that I didn't want to waste on the study guide because I think you know how to do it. I believe in you. All right, so free response I think is what we need a little more work on. Okay. So here we've got this fun looking function. So 2 times the cubed root of x plus 1/2 sine x. So that's that graph from 0 to 4-ish, okay? And they want the derivative. Okay? First derivative, you're only doing first derivative. So we're gonna take the derivative first, rewrite it. So 2x to the 1/3 plus 1/2 sine x. Okay, and I gave a power rule and a simple take the derivative of a trig function. I could have done product rule, so make sure you know how to do product rule. I could have done a quotient rule, make sure you know how to do that. Remember, this is an example of possible things for tomorrow. So 2/3, 1/3 minus 1 is -2/3. Okay. That's a constant, so it stays there, and the derivative of sine is cosine. Now, this right here, people always miss this question. Write your answer as a single term. Okay, that's one thing, not something plus another thing. One thing. No negative or rational exponents. So this is technically the derivative. Okay, and you could stop except for this part. Okay, I need that part. So let's rewrite 2 over 3 times the cubed root of x squared plus 1/2 cosine x, or I'm just going to make cosine x over 2. Then we need a common denominator, so this one is 3 cubed root x squared over 3 cubed root x squared, and this one is needing a 2. So I get 4 plus 3 cubed root x squared cosine x all over 2 times the cubed root of x squared. Oh, there's a 3 down there too. Yeah. So 2 times 3 is 6. This is the 6. There you go. So please, please, please make sure if they ask you a single term, they have it in single terms. Don't lose points because you can't read directions. All right. Based on the graph, will the slope of the tangent line at pi be positive or negative? Okay. What is pi? Pi is approximately 3.14. So you go to 3 and a little bit, and you're looking at this graph. Okay. I think it's negative using a graphical approach. So I need both graphical and analytical. So first, for graphical, you just look at the graph. You say at x equals pi, f of x is decreasing. And we learned that that means the slope of the tangent line. And I highly suggest you just go in and draw that slope of the tangent line. That's not a very good tangent line. Okay, it's not 0, but it's definitely negative. And yes, I expect a sentence here. Therefore, f prime of pi is less than 0, aka negative. Okay, so since it's decreasing, the slope of the tangent line is negative, therefore the derivative is less than 0, or negative. Okay. So that's the graphical approach. For analytical, you're going to actually take the derivative, which we've done here. Okay, I'm actually going to plug it into the first derivative because I feel like that's easier. Or not the first derivative, but the first version we have here of 2 over 3 cubed root x squared plus 1/2 cosine pi. Oh, well, pi. All right, remember, I don't care the actual value. I care if it's positive or negative. So 2/3 times the square root, or sorry, the cubed root of something positive, that's all going to be positive. So a positive value plus 1/2 times the cosine of pi. Okay. Cosine of pi is -1. Ooh, I was supposed to do this at a different value. Whoops. Okay. But whatever this positive value is, it's very, very small. Okay. Plus -1/2. Okay. Tomorrow's going to be more clear cut, but you should tomorrow know that whatever this is, or whichever one is more negative, you'll realize it wins out. Okay? So a negative value. So it should be very clear tomorrow if it's negative or positive. This is not a good question. Oops. Okay. Because I just altered it from the test. All right, so write the line of the equation tangent to the graph at pi. Similar thing, okay? You plug in pi to your derivative, okay? And you get whatever you get. Oh, it's ugly. That's okay. It happens to all of us. We're just going to plug in y equals m, x minus x1 plus y1, graph of the tangent line. Okay, y equals pi. Then you plug into the original, and you're just going to leave it real simple. 2 times the cubed root of pi plus 1/2 sine pi. And sine of pi is 0, so this all goes away. So now you have y equals m, x minus pi plus 2 times the cubed root of pi. All right, now to figure out m, that's the calculus part. You take the derivative, which we've done, and you plug in pi. So I'm going to make this very ugly, but that's okay, by just plugging in pi. Cosine of pi is -1. So y equals 4 plus, no, minus 3 root pi squared over 6 cubed root pi squared times x minus pi plus 2 cubed root pi. Oof. Okay, hopefully tomorrow those questions are a little bit easier algebraically. Okay, same concepts will apply, but I would like for it to not be so intense calculation-wise. All right, where is the function continuous but not differentiable? All right, so if you look at this function, okay, you will never have to pick up your pencil. It's a very smooth curve. So it's always continuous, but it's not differentiable at one point, okay? And remember our reasons. You can tell graphically, okay? One is continuous, or if it's not continuous, it's not differentiable, okay? Another one is sharp turns, cusps, okay? Then we've got vertical slopes and intense oscillations. Okay. Now, if you follow this graph here, right here, for a moment, it goes directly up and down at 0. Okay, that means it's not differentiable because that would be an undefined slope. Okay, so graphically, at x equals 0, the function has a vertical slope. Therefore, f prime of 0 does not exist. Okay, it would be undefined. You can also write undefined in this case. Undefined. All right. If you want to talk about graphically, or that was graphically. If you want to talk analytically, okay, we've got a derivative. We took our derivative. It's not gorgeous, but we took it. Okay. And I'm going with this version before we did any craziness. All right. So we know that's the derivative. And basically when you're asking about differentiability is you want to know where the derivative messes up, where this is undefined, okay? And we already know it's 0. But think about this part of this term here, okay? Cosine is always fine. It's always continuous. It just oscillates up and down. You're fine, okay? But here, if you plug in 0, so f prime of 0, okay, this gives me 1. That's fine. This is an issue, okay, because it's a number over 0. So that's undefined. Since it's undefined, okay, the derivative doesn't exist there. Okay? So graphically, you can see the vertical slope. Analytically, you can see that when I take the derivative at 0, it's undefined, okay, which makes sense according to the picture. Tomorrow it will look something like that, and yes, I need both graphically and analytically, or you will not receive full credit. All right, tomorrow you have 2 FRQs, but today I'm doing 3 just to get us plenty of practice. Okay, there weren't that many quotient rule problems in the multiple choice for your study guide, so I brought